Factors affecting acid strength. The more polar the HA bond, the acidic proton bond, and or the weaker that bond, the more acidic the compound. Acidity increases from left to right across a row and from top to bottom down a group. In oxyacids, in which an OH is bonded to another atom, we'll call Y, the more electronegative Y is, the more acidic the acid. In HOCl, the electron density will be shifted to the more electronegative Cl atom, weakening the OH bond. So the strengths of the acids will be in the following order. HOCl, stronger than HOBr, stronger than HOI. Among oxyacids, the more oxygen atoms in the molecule, the stronger the acid would be. The electron density will be more toward the oxygen atoms, and as the oxidation number increases, the strength of the acid increases. For a series of oxyacids, acidity increases with the number of oxygen atoms. Resonance in the conjugate bases of carboxylic acids stabilize the base and makes the conjugate acid more acidic. So here we have a carboxylic acid, right? So let's talk about what happens when this carboxylic acid donates its proton. So I'll just draw the functional group. So we have C, double bond O. When it donates its proton, the electrons that are in this OH bond, so we have this OH bond, right? As the proton is donated, these electrons stay behind with the oxygen. So the oxygen has 1, 2, 3, 4, and then the 2 green ones. So, and then overall has, this conjugate base overall has a negative charge, okay? But we could kick off this resonance process here where 2 of these electrons could go here and 2 of these electrons could go here. And that creates a resonance structure that looks like this, also with a negative charge. Okay, and then of course, remember, we don't have all the structure on the left or all the structure on the right, or even a mixture of the left and the right. But what we really have is a hybrid structure that exists between the two, okay? And that hybrid structure, or that resonance, stabilizes the conjugate bases that you see all on the right-hand side for the carboxylic acid. So those conjugate bases of carboxylic acid are more stabilized by resonance. Because they're more stabilized by resonance, that makes the carboxylic acid more likely to give up its proton, right? Because the resulting conjugate base is more stable. That makes the carboxylic acid more acidic.